Hello, you two. Welcome back. Hopefully, you had a great Easter and got some rest in. We're going to keep continuing on with our math lessons online. I hope to be back soon, but that's out of our control, and that's just my wishes. I don't know if that's going to happen or not, but hopefully, that'd be awesome because get out of the house and see some people again and socialize is needed for me. But let's go ahead and get started. We're going to start with lesson 86 again, okay? And that is volume of the pyramids and of cones, okay? So if we remember volume, all that is just how much can fit inside a 3D object. It could be a box. We're not talking about a rectangular prism right now, just a normal Kleenex box or a box you get from Amazon. We're not talking about that. They're just talking about pyramids today and cones, okay? So a pyramid can have, that's going to come up to one point at the top. It can have a bunch of different bases. It could have a square base. It could have kind of a rectangle base. It could have an octagonal base. It could have a hexagonal base. As opposed to a cone, when that comes up to the point, that just has a circular base at the bottom. Okay, so we're going to go about how to figure out the volume of that, and let's go ahead and get started. So in example 1, we're going to start there. This says Aiden built 2 cones out of sand on the beach. The diameter of the smaller cone is 6 inches, which you can see in the picture, and its height is 5 inches. Okay, that's talking about the smaller cone on the left. The diameter of the larger cone, remember diameters all the way across, the book is showing you the radius, so that's why the numbers aren't matching up. Make sure you realize that. Okay, the diameter of the larger cone is 12 inches and the height is 10 inches. How many cubic inches of sand did Aiden use for each cone? How many times greater is the volume of the larger cone than of the smaller cone? Well, a couple things we need here. We need to know what is the formula for volume of a cone. And if you look right below the 2 cones, it says that. I'll write that on the board so you can see it. Volume equals 1/3, which means type in the fraction 1/3. Okay, don't use 0.33333. Okay, you got to be specific. And I like to usually put that in parentheses because if you type that in on the calculator, put parenthesis 1 divided by 3 parenthesis. Okay, then that's how you know guaranteed you're going to get 1/3. And then it says pi r squared h. So pi r squared h. So let's just talk. Pi is 3.14. That's what it wants you to use. Or sometimes it'll say use 22/7 for pi. Or sometimes it'll say just leave pi as pi, and which in that case, remember, then we just tag that on our answer. We do not multiply it by pi. We multiply everything else, not pi. We just put that at the end. Okay. This one does want us to use it. I think it says, oh no, it does at the very bottom. It says express pi as pi. So when we do this one, the first one we just read, we will not be multiplying the pi. We'll just be writing it in there. Okay. So I'm going to go and I'm going to fill this out. We're going to do the small cone first. Okay, I'm going to write in the numbers. It says the radius of the small cone is 3. So I'm going to write 3 times 3, because we got to do that, is 9. Okay. Remember, I'm just going to keep pi there. I didn't use it yet. And this h stands for height. And remember, all the things between it mean multiply. So we have to multiply these all together. Okay. The height of the small cone is 5. So let's do 9 times 5, which is going to be 45. And then remember, we still don't have, we just keep it in there, right? It doesn't want us to multiply it. It wants us to leave pi alone. But we still have to multiply it by this 1/3, okay? And you can either multiply it by 1/3 or you could divide by 3. It's the same exact thing. Okay, so I'm just going to divide by 3. I'm going to go 45 divided by 3. It goes in 1 time. Don't forget to drop down the 5. And okay, it ends up being 15. So now we've multiplied all the numbers together we were supposed to, except for pi, because it says at the very last part, express pi as pi. Don't do that yet, right? Just leave it normal. Okay, so my final answer, and remember it's volume, so it's going to be cubed, okay, is going to be 15 pi, leave pi as pi, don't touch it. I forget, is it inches? It is inches, yep, it is inches. Inches cubed. Okay, that is the answer for the smaller cone's volume. Okay, I'll just leave that there for 10 seconds, and then I'm going to do the other one, so you can see. Okay. Okay. Now let's do the larger cone. I'm going to make a little note of that so I don't forget it. It was 15. This was the small, which was 15 pi inches cubed. Okay, just so I remember, because it wants us to compare a member at the end. How much bigger is the big cone than the small cone? Okay, so we got to figure out now the big cone. Let's plug these in. The radius of the big cone, as you can see, it says r equals 6. So it's going to be 6 times 6, which is right there, 36. Bring pi down. Bring the 1/3 down eventually. I like to take 36 times the height, which the height is 10. 36 times 10 is 360 pi. And remember, it doesn't want us to times pi in there yet. So it just wants us to leave that alone. So now we're just going to take this 360 and we're either going to times it by 1/3 or we're going to divide it by 3. Remember, those are the same thing. So I'm just going to divide that again. 360 divided by 3. 1, 2, and 0. Okay? So the final answer is going to be 120 pi inches cubed. That is for the big cone. Okay, I'll leave that and get out of the way here for a second so you can see it. Okay, and then now for the last part, which I will erase this, it wants to know how much bigger is that. I'm just going to take those answers and divide them. I'm going to take 120, the big number, and I'm going to divide it by 15 to see how many times it goes in. Okay, and this one I don't know, so I'm going to just take some guesses here right away. I know 15 and 15 is 30. Oh, I don't know, let's just guess with, we know times 10 is going to give us 150. Okay, so I know if I take 2 away from that, which is minusing 30, it's actually probably going to be 8 if I do the math here. 15 times 8, 8 times 5 is 40. And that's exactly what it is. Okay, so it is 8 times bigger. So there's your 3 answers, okay? There's your third answer right there. As you can see, the 2 on the far right, and then the third answer I just circled, 8 times bigger. So that's how you figure out volume of a cone, okay? Okay, now let's look and take a peek at example 2. It's not going to be a cone anymore, it's going to be a pyramid. So let's take and let's read that one. It says, find the volume of this square pyramid. Notice it says square pyramid. Remember I told you the bases can be a square, could be a rectangle, could be a hexagon at the base, could be an octagon. So in this case, there's a square. Okay, so let's just see what it wants us to do for that one. It says volume equals 1/3 base times height. So here's the formula for that one. Volume equals 1/3 BH. And that just means times them all together. Okay, times them all together. Find out the base, find out the height, and times them all together. So if we go and we look here, it's telling us what they left out. Okay. So actually here, let's see this. Base is meaning the area of the base in this one. Okay, if you notice when you follow that. So it wants you to take the area of that square. And if you notice, the square is 90 by 90. Okay, so to get the area of that, that's what you're going to put in here. I'm going to make a little note just so you know. Area for that one. Okay, so yes, it's 90 times 90, which 9 times 9 is 81, and then add the 2 zeros. So I'm going to write that in. So it's going to be 81, and then add the 2 zeros. Don't forget about the 1/3. Okay, and then now let's times it also by the height, which the height is 50. So, okay. So let's take these two first. 8100 times 50. And I'm just going to go 0, 0, 0, 0, and then start my next row. 5 times 0, 5 times 0, 5 times 1, and 5 times 8, which is 40, for an answer of 405,000. Okay, so I'm going to rewrite that. I'm just going to kind of move it this way a little bit. These two combined into 405,000. And don't forget, we need to take it times 1/3 still. We have not done that. Okay, so you have 405,000. And now again, you can either times it by 1/3 or you can divide it by 3. And for that, I'm just going to do that. Divide by 3. It goes in one time. Drop this down. There's a 0. 3 goes into that 3 times. That's 9. Drop that down. Okay, and then I got 15. How many times does 3 go into 15? That's 5. Don't forget to put your comma. And then we have 3 zeros at the end. But since that already equaled 0, 15, right? 3 into 5 equals 15. These 3 at the end, you just add them up to the top. Okay, so the volume of the square pyramid here is going to be 135,000 centimeters cubed. Now, I'll get out of the way, and you can kind of see that, but I'll just say something. You may be asking, well, why did the last one have pi, and why does this one not have pi? It has to do with the base. Okay, notice the base of the first one we did, which was a cone, that's a cylinder. I'm sorry, that's not a cylinder. The base of the cone is a circle. Okay, and the base of this pyramid was a square. So that's why this was changed to, hey, what's the area of that base, of that square? Well, it was 90 by 90 were our dimensions, and 90 times 90 equaled that. So that's why the volume changed there. Okay? Go ahead and erase that one. Okay, and then we'll do example 3 as well. And we'll go from there, okay? So this one is a triangular pyramid is shown. If you look at the bottom of that pyramid, the base is a triangle. That's why it's called a triangular pyramid, okay? The area of its base, which we need to know, the area of the triangle on the bottom, is 36 root 3 units. 36 root 3 units. Its height is 10 units. So again here's the formula. Volume equals 1/3. And then remember, this is the B, but the B stands for area of base. Okay? That's what the B stands for, the area of the base. And they told us that in the problem. And then also times the height. So the area of the base, they said, was 36 root 3. So I'm going to write that in. 36 root 3. That's all. That's the B. That's what it is. That's the area of the base. 1/3. I'm gonna space it out so it looks a little easier to read. But we still know that we need to times all of these together. Okay? And the last one is the h, the height, which it said was 10 units. Okay? So now, this is going to be times 10. Now, you don't take the 10 times both of the numbers. You actually aren't even going to take the 10 times this one either. You're only going to take the 10 times the very first number, not this back number, not the root 3 number. So we're going to do 10 times 36, and this is going to turn into 360, and we didn't touch this root 3, so you got to keep it the same and put it in there. Okay? And why it's represented as root 3, it's a more accurate representation than with decimals, that's why. So that's why people use that. And then don't forget we got to times it by 1/3. Or you can divide by 3. Now, you don't divide both of these, just like we did the 10 times the front number. We are going to do times 1/3 with the front number, or divide it by 3. So I'm going to divide by 3. 360 divided by 3, and you get 120, but that's not it, remember. Don't forget to add on the 120 root 3, and there were no units, so you say units. And you say units cubed, remember, because we are talking about volume. So I'll get out of the way so you can see that work there. Okay, so I hope that helped alleviate some issues with this one. And remember, if you have any questions, we are on Wednesdays at 12:30 and Thursdays at 2. So hope to see you then, and hope you have a good day. Thank you.